Alright, so in this problem, I have x to the power of 3 plus x to the power of 2 is equal to 2. So to solve this, I'm going to first start by subtracting 2 on both sides. So then these two cancel out. And I have x to the power of 3 plus x to the power of 2 minus 2 is equal to 0. Now negative 2, this is the same thing as negative 1 minus 1. And now I'm going to rewrite this as x to the power of 3 minus 1 to the power of 3, because 1 is the same thing as 1 to the power of 3, plus x squared minus 1 is equal to 0. And 1 is the same thing as 1 squared. And now if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. And a squared minus b squared, this is equal to a plus b times a minus b. So x to the power of 3 minus 1 to the power of 3, that's going to equal x minus 1 times x squared plus x times 1, which is x, plus 1 squared, which is 1. And then now I have this plus x plus 1 times x minus 1. And this is all equal to 0. So now, if I factor out x minus 1, I get x minus 1 times x squared plus x plus 1 plus x plus 1 is equal to 0. And if I simplify, I get x minus 1 times x squared plus 2x plus 2 is equal to 0. So now this gives me two equations. I have x minus 1 is equal to 0, and I have x squared plus 2x plus 2 is equal to 0. So for x minus 1 equals 0, x is obviously equal to 1, so that's one solution of x. And for x squared plus 2x plus 2 equals 0, I'm going to rewrite 2 as 1 plus 1. So now x squared plus 2x plus 1, that's the same thing as x plus 1 squared. So I have x plus 1 squared plus 1 is equal to 0, meaning x plus 1 squared is equal to negative 1. And you can't square something, you can't take the power of something and make it equal to a negative number. You can't take the power of a positive number and make it equal to a negative number, meaning this is wrong. So my only solution for x is 1. Alright, so in this problem, I have x squared minus x to the power of 3 is equal to 12. So to solve this, I'm going to first start by subtracting 12 on both sides. So now I have x squared minus x to the power of 3 minus 12 is equal to 0. Now I'm going to multiply both sides by negative 1. So now I have x to the power of 3 minus x squared plus 12 is equal to 0. Now to actually find all the solutions of x to this problem, I actually need to first start by finding one of them, and using that one solution I can find the rest of them. So to do that, I'm actually just going to start by plugging in values of x and seeing if any of them will work. So 1, if we plug in 1, that's obviously not going to work. So let's go ahead and try 2. So if I plug in 2, I get 2 to the power of 3, which is 8 minus 2 squared, which is 4, plus 12 is equal to 0. 8 minus 4 is 4, 4 plus 12 is 16, so 16 does not equal 0. So now let's try negative 2. So if I plug in negative 2, I get negative 2 to the power of 3, which is negative 8, minus negative 2 squared is 4, plus 12 is equal to 0. Negative 8 minus 4 is negative 12, plus 12 is 0. So 0 equals 0, meaning my solution for x is negative 2. So this is one solution, and now using this solution, I can actually find the rest of my solutions. So how I'm going to do that is I'm going to divide this by x plus 2. Because our solution is x equals negative 2, we're going to divide this by x plus 2, because if I plug in negative 2 for x, negative 2 plus 2 is 0. So now, if you go ahead and divide these, you should get x plus 2 times x squared minus 3x plus 6 is equal to 0. So now I have two equations. X plus 2 is equal to 0, which we already know that x is negative 2. We already know this is a solution. And x squared minus 3x plus 16 equals 0. And if I go ahead and solve this by the quadratic formula, I get that x is equal to 3 plus or minus the square root of negative 15 over 2. And the square root of negative 15, that's the same thing as the square root of 15i over 2. Alright, so in this problem, I have 45 to the power of x is equal to 90. So to solve this, I'm going to first start by taking the log on both sides. So now I have log 45 to the power of x is equal to log 90. Now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this is the same thing as b times log a. So in this case, I have log 45 to the power of x, and I can move x to the front. So now this is the same thing as x times log 45, which is equal to log 90. Now, if I divide both sides by log 45, these two cancel out, and now I have x is equal to log 90 over log 45. Log 90, that's the same thing as log 2 times 45. So I have this over log 45. And if I have something in the form log a times b, this is the same thing as log a plus log b. So now I have x is equal to log 2 plus log 45. Now I have this over log 45. So now this is equal to log 2 over log 45 plus log 45 over log 45. And now log 45 and log 45, these two cancel out. So now I have x is equal to log 2 over log 45 plus 1. And if I have something in the form log a over log b, I can write this as log base b of a. So log 2 over log 45, that's the same thing as log base 45 of 2, and I have this plus 1.